In this video, we're going to learn about slope-intercept form of a line. It's kind of the workhorse in terms of how we work with lines. There's a couple of other options, but this is really the one that we'll use a bunch, and you'll see it a bunch in future classes. For that, we'll learn to write equations in that form. We're going to graph using the slope and the intercept, which is actually a really good way to graph things. We'll look at a couple of special cases, which is horizontal and vertical lines. And then we'll write an equation line given kind of a verbal description. So slope-intercept form is, this y equals mx plus b. And I'm going to write that a little bit larger down here. So a couple of ways of thinking of this. B is the starting amount, so when we get down to the verbal descriptions, we'll see that, the account has $700 in it. That's going to be a starting amount. And it's also the vertical intercept. So it's our y-intercept that we saw a few sections ago. So when x is 0, all this drops out and we're left with b, and that ends up being our vertical intercept. M is going to be slope, like we saw in the last section, so it's our rate of change, and it's going to be what's in front of x. So to find the equation of a line, the two things we need to find consistently are slope and y-intercept. For this first problem, we're given this, standard form. Standard form is another form that you can run into in terms of lines. This equation right here is actually almost in it. If I brought that 3 over to that side, that would be standard form. And it's just the x's and y's are on one side, and it has a constant on the other. We don't use this one nearly as much as we will use slope-intercept. And I'll come back to these two, the two special cases for horizontal and vertical lines a little bit later in the video. So looking at this equation, we're asked to get this into slope-intercept. And so to do that, what I want to do is get y by itself. So I would add the 3 over, and I'll subtract the 6x over. And that will get both of those terms away from this one involving y. So it'll be minus on the 6x because it's subtracting, and then we'd add the 3. And then from there, it's supposed to just be plain y equals rather than 7y. So we will just divide everything by 7 to finish getting y by itself. And then you just have to be a little careful that you divide all of the terms by 7. Not just the slope, which is what people have a tendency to do. So that means this would be y equals negative 6/7 x plus 3/7. So the slope in this case is the negative 6/7, and the y-intercept is the 3/7. Dependent on the question, it may have you enter that differently. Careful that if it wants an ordered pair versus the version where you just type the 3/7 in the box, but sometimes that hangs people up. For this next equation, or example, we're asked to find this equation of the line in slope-intercept form based on this graph. So again, the two things that we need to work out are the slope and the y-intercept. Y-intercept's pretty easy. It's right there. It's 2. So that one we can see pretty cleanly. The slope, something that makes this a little bit harder, is that this graph is counting by 2's instead of counting by 1's. And so what you might do there is actually go back to your definition for slope. So slope is rise over run. And just look between here and probably this is the next point that I can read pretty comfortably where it's crossing on the hatch mark. And then you can just read those distances right off the graph and then reduce your fraction. So here's the triangle. This distance is 2, and that's our run. And then this distance is 2, 4, 6, 8. But be careful there because it's negative 8 because it's decreasing, right? It's going downhill. So that means our slope is negative 4. And then once I have those two things, my slope and my y-intercept, writing the equation line is really straightforward. We just have y equals mx plus b. And so it'd be y equals negative 4x and then plus 2. Then we have graphing using slope-intercept method, and it is far and away, if you're in y equals mx plus b, it's a really straightforward way to graph. So up in the box that I started with all the definitions, I had said that think of the y-intercept as a starting place, and that's exactly what we're going to do for these. So for this graph, we know it goes through when x is 0, y is 2, so we know it's going to go through that point right there. And that gives us a starting place. And then we can look at the slope. So that's our rise over our run. So we're going to rise, starting here, we're going to rise -3 because it's a negative slope. So 1, 2, 3. And we're going to run 1, 2. And then there's our second point. For the computer, that would draw it for you. On paper, we would just connect those with a line. For this one, we'd be starting at -2. And then, remember, 2 is like 2 over 1 in terms of slope. So it's going to run 1 and rise 2, and there's our 2 points. So a very easy way to graph lines. This next one is a bit more of a bummer, and it's because the graph is again counting by 2's instead of counting by 1's, which would make this 2/3 a lot easier to graph. I have it right here from the homework. So I'll show you how this would look just in terms of doing the input. Something else that's different is we don't have the y-intercept. In this case, we have this point. Having a point is totally fine. We would have when x is -6, y is -2. There's no reason we have to start on a y-intercept. We could start graphing from a different point, and that's exactly what we're going to do since they gave us that one. This has a slope of 2/3, so that means it's going to rise 2, and then it's going to run 3. So here, if you look, each box is 2 units, right? So that means we're going to rise 2. And then we have to run 3, so we're at -6 right now, which means I need to go over to -3 is where my point would be, or you can think of -3 as being halfway between 0 and 6. So I just have to bring my cursor over, and it is indexed to stop on the quarters and the halves. So if you just put the little red dot near that 1/2 mark, it'll get it set up in there for you. So that's how you handle that one in terms of the computer. So these are our equations of lines, of horizontal and vertical lines. And back in that definition box, there was y equals b, and anytime we see that, it's going to be a horizontal line. The reason that is horizontal is, let me see if I can actually, no, that's set in there now. Oh well. I was going to see if I could delete that for a little more room. We'll go right up here. So if I have y equals 3, the reason that's horizontal is because what that means is it doesn't matter what x is, y is 3. X can be any value. If I graph this when x is 0, y is 3. When x is 1, y is still 3. If x was 4, it would still be 3. You can see I get a horizontal line through y equals 3. It's really easy to get mixed up on these because you think y-axis, it runs vertical. But when you actually make a table for what that would do, you get a horizontal line. The slope on these is 0, because if we think of our rise over our run, this one would have no rise, because it's not going up or down, it's just staying constant. And it can have any number for the run, but 0 divided by a number would be 0, so for that one the slope would be 0. And if you think of flat, if you think of hiking and there's no slope, or the slope is 0, you would think it would be a flat hike. This one, on the other hand, if x equals -2, what that means is it doesn't matter what y is. Y could be 0, y could be 1. X is always going to be -2. So if we go over to x is -2 and y is 0, x is -2 and y is 1. And so any value I pick for y, I'm just going to keep stacking up on this vertical line right here. For this one, for the rise over the run, this one has no run. The run is always 0 because it doesn't have any horizontal change. The y, that could be any number. And when we divide or try to divide by 0, that is undefined. Or for the computer, you would write d and e for that slope. I'll just put it there. The hardest thing about these two, I think, in terms of exams, is people forget that they exist. The definitions for both of those are in the notes that will come with the exam. They're up in this box up here. Although my typesetting is a little off, I think that's supposed to be tabbed over. But so if you just remember that's there, that can help in terms of the test. And then these last few questions are just identifying the slope and the y-intercept in a verbal description so that we can write the equation of the line. So for this first one, Grace opens an account with $250. Every week thereafter, she withdraws $55 from the account. If X is the number of weeks she's had the account, then Y is the amount in the account. Find an equation of a line of the form Y equals mx plus b that describes her balance. So for that, remember that Y is a starting amount and then M is a rate of change. So Grace opens an account with $250. That is definitely a starting amount. And then how is it changing week to week? It's decreasing by $55. So that's a slope. So, and since it's decreasing, she's withdrawing the money. It's going to be negative 55. So then when we go to write that, we'd have y equals negative 55x plus 250. And that's probably the way I would type it into the computer. You can also think of it as this way. She's starting with $250, and then every week, for each week that passes, it's going to decrease by $55. So I think in terms of the words, it makes more sense this way, but that's kind of more of our standard mx plus b form. This next one, on a bicycle, Carla starts 5 miles from her house and rides 12 miles per hour away from her house. Write an equation to model the situation. Use d for distance from her house and h for hours. So we have to decide, this could be one of two things. It could be, in terms of the ordered pair, it could be dh, but it could also be hd. We don't know which one is x and which one is y yet until we stop and think about it. So we definitely want to stop and think about it. So for starters, let's figure out what we know from the description. She started 5 miles from her house. That's got to be a starting point. So our intercept is going to be 5. She's going to ride 12 miles per hour. That's a rate of change, right? Because if she rides for 1 hour, she goes 12 miles. If she rides for 2 hours, she goes 24 miles. So that's going to be our slope. So we have to think, are we putting in hours and getting out distance? Or are we putting in distance and getting out hours? Our y-intercept is, I'll just call that 5 right there. And it's 5 miles from her house. This is a distance. So that tells me that the hours are my input and the distance is my output. But you have to be careful because down here, the way they wrote the sentence, it made it sound like this one, which it's not. So you do have to just stop and kind of give that some thought as to what you're plugging in, what you're getting out. So anyhow, after all that, we would have our distance is what we're getting out. 12 is our rate, times the number of hours that she rides, plus the starting amount 5. So if she was starting 5 miles from her house, if she rode for 1 hour, she'd be 17 miles from her house. That all makes sense with the description they gave us. And then this last one, suppose we're in a submarine 30 feet below the surface. There we go. You're ascending at a rate of 20 feet per minute. That sounds like a rate right there. And this sounds like a starting amount. Write an equation in slope-intercept form to model the situation where d is the depth and x is the time in minutes. So kind of just looking at the graph that they gave us and recognizing again that if we're going to identify b B would be the 30 feet, right? That's where we'd be starting. So that means the y-axis is depth, and then the x is the time in minutes. So x, putting in x's is getting out d's. Our rate would be, we're ascending at 20 feet, so that means it's going up at 20 feet per minute, so that would be our slope. And so then that would make our equation, careful to use d instead of y there, so d equals 20x, and then minus, not plus, minus 30. Sorry, that should have a minus on it because we are below the surface of the water. So we're starting here at minus 30, and then we'd be going per 1 minute, we would go up 20, and so think of 20 minus 30 would be at negative 10 right there. And that would be our graph that they asked for.